Hello and welcome everyone. This is the Q&A session for processes and planning. And what we are going to do today is to look at 4 chapters in this book, or preferably you should already have read those, seen the videos and looked up the question and study material available on I just want to see, well, that's me. That's available on Moodle. So the idea is that we should have a discussion. We should have a discussion concerning the stuff that's inside these 4 chapters, and I will try to well, perhaps give a few more clues about what's actually in this, and if there are questions, the idea is that I should be able to answer. But I will also pose questions to you, and I'd like you to answer, so I will hand the mic around and you can answer what I say. This is an opportunity for you to see to that you've understood the material, and therefore mic noisy. Brusade för alla. Is it better? Let's see if I could be. I will hand that around. Probably problems with connection then. So I will hand the mic around, and I will have some answers from you as well, hopefully. The reason for doing this is also that there will be an online test from tomorrow to Friday, and the test will work like this. There is a link on the Moodle page. On this Moodle page, when you click it, you will come to a test, and it will start tomorrow at 9. And you have, when you commence the test, you have 30 minutes to complete it. And there will be 10 questions about this, and they will be randomly picked from about 40 different questions. So all of you will have a different set of questions. And when you complete the test, you will get a page where it says if you passed the test or not. If you, for any one reason, did not pass the test, there will be an additional test a little later, and then a 3rd test in August. But in order to know the answers, you need to well, of course, read the book, but it will help to see the lectures as well. So that's the idea. I will begin looking into this book, and I will do some talking, and I will ask a question or two and try to explain. And you on Slack, you're welcome to try to send in questions and answers as well, if you like. So there are 4 chapters concerning processes and planning. The first is about processes, and it's chapter 2, where the objectives are to understand the general idea of a process. Why do we have them? What's the idea of a process? What does it contain? And so on and so forth. And basically all of this comes from the time when we were, well, before we were seeing this as software engineering. So from the time when programming was done by people in white lab coats, and they were very, well, nerdy, and the buzzing is really loud still. Okay, is it any better now? They can't hear me because of all the noise. I think it's you who are making the noise. Let's see. several people are typing. Cool. It's like a heavy rain. I feel the urge to sing Purple Rain now, but I won't. Like a waterfall, as an old recording. Okay. Let me run away. Well, let me run away. And I'll see if I can talk with a technician. Behave. And I'll be back.
Ska se om jag kan höra i lurarna kanske. 1, 2. Ett, två. Är du eko?
Okej. Bra.
Hur kan det bli det? Ska se. 1, 2. 1, 2. Så ligger det dubbelt. Testing. Jag lämnar över den till dig. Det är inget punkt eller något annat som står där. Så ska jag undersöka under tiden du kör.
Okej, så jag kör.
Det är bara att det är lite...
Ja. Så jag kör bara då?
Ja.
Okej.
Du ska inte ha fel.
Nej, det ska jag inte. All right then, let's continue. You will have to, well, over there. You will have to make do with the noise for now. We have a professional technician working on the problem 24/7 now, and hopefully it will be better. And go on, it's not that bad, they say. Great. Then perhaps I should be singing as well then. Okay, so to continue, the idea was that during the late 50s, something like that, they realized that all software projects, more or less, were too expensive, not delivered on time, and so on. So they needed another way to approach software development. And this is about this time when they developed this software engineering process instead, or rather the idea of seeing software development as something that's an engineering profession. So that meant, for example, to use an organization around it and to structure the work into different things. And these different things and how this organization works is the topic of this Q&A. And there are basically 3 different ways of approaching, in the general case, software development, with three different models, but also way of thinking about these software processes. So, does anyone know what these 3 different ways of doing it are called? Well, we're talking about the Waterfall Model. We are talking about incremental development and integration and configuration. So, one of the first ways of approaching this in a more software engineering way was this Waterfall Model. And you've probably heard of it. So you can tell me, what is it? I'm not sure, no?
A process that doesn't involve customer integration that much as the others do?
Yeah, so yeah, exactly. I'll just rephrase. Yeah, it does not have that much customer integration, but it's even more than that.
It's mainly for hardware projects?
It's especially good for hardware projects, yes, correct. And as they say over here, one task after the other. So that's the reason why it's good for hardware. So the idea was that you have a number of steps to take, and these steps are done more or less, at least in isolation, meaning that you begin with, and in this case let's just take the steps that they say. You begin with a requirement definition, and you move on to system and software design, and then implementation and unit testing, followed by integration and system testing, and operations and maintenance as the last step. And this is what we call a plan-driven development, because you do everything according to a plan. That means that the first step, called requirements definition in the book, also known as requirement analysis or just plain analysis. All of these steps, all of these names are the same step, but it's all about what? So analysis is all about not only about documentation, but well, yes, you do a lot of documentation, but on what? Yeah, and basically what that means is that this first step is about understanding what to do. So analysis or requirements analysis or requirement definition, it concerns everything that has to do with what. What are we supposed to build? And the reason why we are going through most of these different parts is that these steps are the foundation of almost any software process later on as well. However, we may do them in different ways, or redo them, or do them in another way, or whatever. But the idea is that you always begin somehow with analysis, trying to understand what to do. This in contrast to software design or just design. So if we want to put just one word about what design is, what would that be? Exactly, how. So analysis is what and design is how. Analysis is completely, or should be completely, technology agnostic. So the idea is that during the analysis we define exactly what we want to create. Perhaps a web shop where a customer is going to be able to register, and we are going to put products in it, and we are going to be able to change information about the products. We are going to manage our customers. We are going to display the different products, and so on and so forth. And it's in no way depending upon how we are going to do it. Whereas design is much more about how to actually design it. What kind of programming language or framework or whatever else it might be, database, are we going to use? Design usually is about finding out and defining in what specific way we are going to implement this. So therefore, analysis is very much with the user, the end customer, whoever that might be, whether design is much more to support the programmer and the implementation. And implementation, well, you know that, just going down coding. However, the idea is that if you've done a good analysis and a good design, implementation should be fairly easy. It never is, but it should be. And if you've listened to Jesper's lecture, he really sees this vision of model-driven architecture somewhere in the future, where you just draw up diagram after diagram during analysis and design, and then you push a little button and out pops the program. It ain't never gonna work, but it's a vision. It's something that we can strive for at least. So implementation is something that should work fairly easy if the previous steps were well done. And then we have testing in different ways. We have a unit testing, of course, in implementation, but after that we test in higher and higher levels. And lastly, operations and maintenance, which is the life after we've done it. Sometimes we see deployment here as the last step, but we don't always just deploy. We make it we make it a project that continues to evolve later on, because we do patches and updates and so on. So we have analysis, design, implementation, testing, and maintenance or deployment. Which of these steps do you think takes the most time? Yeah. So maintenance will take a lot of time. Okay. That was one of the important first processes, and it really helped. And just as you said over there, or somewhere about hardware, it's especially suitable for hardware. And why is that? I'll take some water, or at least it looks like water. Oh yeah. Now, well, when it comes to hardware, we know from the definition of the hardware how that works. So a lot of the requirements, so to say, are already set. It's fairly, I wouldn't say it's easy, but it's easier to create, say, a Mars rover, because we know what we want it to do and we know how it should do it, because we have the hardware, and the hardware itself might change and so on. But we decide basically how the hardware works, and we can fit that to our needs and so on. However, as soon as we begin creating things for humans, there's a large problem, because humans do not always know what they want and how they want it, or how it works, and so on. And I've worked a few years in industry as well, as a IT consultant or something, I don't know. I got paid, so I did what they said. And one of the biggest problems we had there was exactly that. When we wanted to talk to our customers to try to find out what it really was they wanted, because they didn't know. They had a general idea, but they had no idea exactly how that should be accomplished. Okay, so apart from waterfall model, we have incremental development. What's that? I've got all day.
When you have manual iterations and do something like that.
Yeah, basically, what you got is something something that you build that you do in increments. So you build upon it in one way or another. As you said, it could be done in iterations, or you can find phases in which you do specific parts of it or whatever. So there are different ways of implementing a incremental development, but it's a lot more interactive or built on prototypes or on code that we try to make better along the way, instead of having these watertight shuts between the different phases. And the agile methods, which is the next chapter in here, is an so to say extreme version, basically, of this. What's the Swedish word for increment? I get the question. It's increment. And right now I don't have a better word for it. It's a small piece, a sub part of what's going to be created. And the Swedish word is increment. We'll have to look that up if there's another better word for it. So the addition to this is, of course, or the improvement in contrast to waterfall is, of course, that you can see the product evolve during time, instead of being certain at the beginning what it is we want to create. So integration and configuration. Oh, let's see, we've got a reply for that one. Tillägg kanske? Perhaps. So integration and configuration, what's that? Yeah, exactly. It's working with software development as if it was more or less Lego bricks. So you take different parts that are already finished and you put them together. And just as building Lego isn't that simple all the time, this isn't either. So this in the book they mentioned that this could be on many different levels. So we could say that using a predefined framework like Java Spring or anything similar could be using this integration and configuration. I'm not that keen on that idea. On the other hand, if we look at really large systems like the ones supplied from SAP or Oracle or IBM, these systems are many times constructed in the way that they have a set of, let's call it subsystems or parts that you can use. So you customize what parts you want to buy from, say, Oracle, and they have or really especially SAP, and SAP have really expensive consultants that will help you to customize and integrate these different parts. So you might have, you might buy the part for invoicing, or a part for customer relations, and a part for something else, and you want these different parts to talk to each other. And ASP and Oracle and IBM, they've of course made it possible for the different parts to talk to each other, and that's what you pay them for when they construct your system, as well as tiny little additions that you might do, like for example adding your logo somewhere, or some specific text about your company, or whatever it might be. So customizations and, as they say, integration of the different parts and configuration of these different parts into the system that your company needs, that you are buying. And even though this sounds like just putting Lego bricks together, it's something that's fairly complicated, and it needs to be seen as a software development project as well. So you need to have people, you need to have increments or iterations, or use any of the other ways of developing software as well. But it's something that we see a lot more about as redoing or reusing the things we already have is quite a good idea. So we don't need to do it again and again and again. And that's basically what we did on that IT firm that I was working on previously as well. We had a set of software tools or programs, and we customized that to the customer so that it worked as they intended it, and also to bridge to other pieces of software that you might have. So you might already have a customer relationship system, then you want to get information from that to your new system as well, and that's something that you can develop. Will integration and configuration projects be more dominant in the future? Well, I'd say it's already dominant for large projects. So like the enterprise relationship systems, the ERP systems that we see out there. There you will do it like this. For smaller projects, well, if you, like the book say, you use this if you use a predefined framework and so on, then yes, of course there will be more. But I'd say that for most projects, the other ways of doing it will be more used. Okay, so the book goes on to look at these different process activities: the analysis, design, implementation, testing, and deployment, maintenance, and so on, in more detail. We will not look into everything here, but just so that you are aware of analysis, requirements analysis is often put into 3 steps: elicitation, which means getting the requirements, the specification, and the validation. And I'd like to talk a little bit about this, or rather hear what you have to say about, for example, requirements elicitation, where elicitation means something like collecting the requirements. How do we do to get the requirements from the customer? What ways can we use in order to get the requirements? Are they just handed down by a mythical, magical, bearded man? Or is there actually some work involved in getting the requirements? There is. Ask them, yeah. Just that's one of the first things. So basically, the way it usually works it depends on the project, of course. But You often get post-it sessions. That's good. You get an idea from the customer. We want this, and then you need to sit down and basically interview the customer. And the important thing here is book meetings and engage them. Great. The important thing is that we most often have a number of people that we need to talk to. The way it worked, where I worked previously, was that we had one contact person, and the company we worked against, they mainly wanted us to talk to this one guy, and he wasn't the sharpest knife in the box. So we always needed to talk to other people, and we need to talk to the ones who are actually going to use this, or who are actually doing something similar to what we are going to develop a system. So one of the systems we did was to fetch data information about minerals, and I don't know anything about minerals basically. So we needed to sit down and talk to the people who were doing this today, and ask them, how do you get the information you need about the minerals that you need to know of? But apart from just asking, what else can we do? Make things up? No, not a good idea.
Are you referring to user stories?
Yeah, well, not specifically user stories, but that's a great thing. That's something that you should do when talking also to the customer, interviewing them, and ask for them what can we do, or rather, how would you like to work with this? And then we get user stories. So that's a great thing, and they say user stories over here as well, which is great. Okay. I was thinking about perhaps observing people when they work. This is especially good when you want to create a new version or a new software from the old software. But also, as we did in this case, we looked at the people. How are they collecting data for the different minerals? How do they find the information, so that we know how to collect it and get it? They also say observe existing systems and workflows. Great. Making a prototype and basic UX stuff and so on. Yeah, all of that works. Will this live stream be uploaded later? It is being recorded. We'll see if it will be publicly available, because I'm giving out a lot of secret stuff now about minerals. No, I'm not. But prototypes is one really interesting thing, because from our point of view, it's most often the case that we want to show this is how we think that the workflow will be in your new application. And I did this exactly this for this other company working with minerals, and the only feedback I got back was that the unit I had used for a specific mineral in my examples were wrong. So it should be grams per something, not kilograms per something. That was the only feedback. So really important when we do prototypes that we fill it with real data and not made up data. The next step here is requirement specification, and we've already touched a little bit about that, because user stories is a great way to specify, because specify means that we need to put the requirements down to something. Writing down user stories is one way. writing use cases, or just listing the requirements with an unambiguous way is great, because the last part, requirements validation, is what's important with the requirements. We don't do the requirements in the beginning and then just have them in the back of our minds all the time, and especially when we get to testing, we need these requirements to test against, because they are what we were supposed to do in the beginning. And it is then really important that we actually do this unambiguously. So we cannot have requirements as the system should have a nice GUI. That does not work, because we cannot tick that one off. We need to find things that we can tick off and say, well, we've done this, we've done this, we've done this, we've done this. Yeah, we don't need to linger on that. We need to move on to a little bit about design, and that's also because it's most often difficult to really understand the differences between analysis and design, whether as implementation and so on. It's fairly, I shouldn't say it's easy, because they will kill me out there if I do, but it's at least more easy to understand the differences. But design, as you said, is about how to do stuff. And then we have architectural design, database design, interface design, and component selection and design, where we can create the architectural design with a relationship between the different subcomponents, modules, whatever it might be. Database design is how we design how the information, the data, is going to be stored. Interface design is how the different components are supposed to talk, so the API of our system, basically. Component selection and design is to pick up the different components that we want to use. Testing, you'll get loads of testing as well. Yeah. Oh, there's so much. Please look in the book. I'd say it's you have a number of well, questions that you could ask yourself on the model page. We try to specify a number of things that you should be able to answer when we're done with this theme, and that's under study material, and you should really go through those. And before that, I also point to a number of different exercises in the book that you could do. And by doing the exercises, I mean it's not the case that you should be writing down essays on everything, but some of the things that we have here is to suggest a generic software process for, and then there are a number of things. For example, a system to control anti-lock braking in a car. Would we use waterfall or incremental or configuration for an anti-lock braking system? Yeah, waterfall would probably do nicely in that case. Whereas an interactive travel planning system that helps users plan journeys with the lowest environmental impact, that would probably not use waterfall, but rather incremental. And as I said previously, if we take incremental to the extreme, we get agile, which is the next part in this book. What do you know about agile software development? yeah, short iterations, basically. So shorter iterations for doing things, but incrementing the software. So we're building on the software, having many small iterations, creating a better piece of software by making progress down the way. Why would we like to do it like this? Why not just made by developers for developers? Yeah, it is. However, it's made for developers because management is a problem also. We need to get stuff done, but what specific problem is it that we want to address by making short iterations and incrementally building our software? Yeah, so what the book calls coping with change. So it's a lot easier to handle that something goes bananas, right? Changes, great. They're on to us. I think they are listening. So we want to be able to rapidly make changes, and the reason we want that is, of course, as we said previously, it's hard to define exactly what we want to do in the beginning, especially when we work with human beings, and we often do. So short iterations, increments, and so on. And these agile methods arose late 80s or late 90s, I should say, perhaps, rather. And they have a manifesto that's really interesting, a number of ideas that no matter what specific agile method you choose, or methodology, or process, the idea is still that they should always adhere to these specific ideas. And I'll read them for you, and we will discuss them because they are important. So they value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, or responding to change over following a plan. So they remove a lot of the documentation, and this was also one of the reasons why this came at the time that it did, because we had loads of software projects by this time, and these projects, they again ran over budget, and they weren't finished in time. And one of the reasons for that was that we really tried to document everything. So there are examples when documentation took more time than the actual work with the project itself. And this they wanted to address by having interaction with people rather than having to strictly follow a process, working software instead of a lot of documentation, meaning that this is something that we do a lot more together with the customer, together with the people in the group. And this also means that we very much like to just move the project forward and do all the stuff that we have and understand the stuff and do the right piece of software, the correct piece of software in the end, instead of negotiating contracts. This is problematic. This is perhaps the most problematic part of Agile, this customer collaboration over contract negotiation. And why is that, you think? Why is that so problematic? I'll take some water. It is water, I promise. It's a 50-50 mixture of Kalmar and Växjö water. It tastes like water. Now, the problem here is that above the individual programmers and above the project manager and so on, the people that are really involved in this project, above them is management. Management wants to sell software, and they sell software to a customer, and they talk most often, I'd say, to management on that side. And management on that side wants to know how much it costs and when it's finished. And management on our side wants to know how much they can sell it for and when it will be done. The problem is that using this, the software will be done when it's finished, and it will be the software that we really wanted. Okay? But doing that means that we cannot say exactly when things are done and how much it will have cost. I've seen studies that say that doing it this way for software development makes better software, but also it will make better software. So you get the system that you actually paid for. But this is a really hard sell for management or sellers or whomever it might be, because they want hard facts. They want to negotiate the contract. They would rather, and I know this from experience, they would rather write paragraph after paragraph about what happens if we are not done, what happens if you change the requirement, who is to blame and how much will it cost. And I've seen these contracts, and they're not very suitable for us who really want to create the software. And we got a question here on Slack. Isn't there a problem with the incremental method as a product always changes? I'm thinking of mobile apps that are being updated every week. The user gets confused because they have to relearn the product constantly. Also, some weeks the product doesn't work as well. Yeah, but that's true, and one of the inherent problems with incremental software development is that you add to a code base all the time, and sometimes these additions will not be as well integrated into the old code as it might have been if we knew everything from the beginning. So there is a great problem there. When it comes to mobile apps, I think we are taking all of this to the extreme, and what you're referring to is certainly true, that they update the application all the time, but I think that the software development we are talking about is for the time before the software is really released. So when you have released your software, it will of course be the case that you need to make changes to it and so on, but that's during the maintenance phase and so on, or you open it up as a new project or so on. But we are talking about the time when we have many increments, and when we are done with the increments, then we release the software to general public. Okay, and as we said, responding to change over following a plan. So yeah, coping with change, that's good. There have been a number of different agile development techniques, and one of the first one was this XP. Have you heard of that? It was really in the rage for a few years ago. What do you know about that? What's important with XP? What does it stand for? Yes. Extreme programming, and what is the thing that's a bit different about it when compared to how we normally do things? Pair programming, exactly. So you were supposed to work in pairs, and you were not only supposed to work in pairs, but you don't. If you take this to the extreme programming, then you don't have the same pair all the time, but rather different pairs, perhaps each day. And what was the idea of a benefit from this? What benefit would we get by doing it like this? Less errors, yes, because 4 eyes instead of 2 eyes. More interaction between the people doing the coding, less false starts. So we were concentrating on doing the exact right thing all the time. So a better understanding, and this is something that we encourage you as students to do as well, to program in pair in order to have a discussion on the best way to solve a problem. Will this give us better code, more efficient? Is pair programming better than just one person doing the coding? Yeah. Yeah. So really mixed results. No one knows. It might, but it might not. So generally we don't know, and we just, well, there's not a lot of hype around this anymore, because, well, it didn't give that certain benefit that they wanted. They also have this test first development approach, which later led to test driven development. And what's that? Yeah, writing the test before development. How does that sound? Really boring, yeah. Yeah, is it a good idea? Probably a really good idea. However, I mean, that's not the fun part of programming, really. And I'll get the other teachers telling me otherwise later. But I mean, coding the real shit. Oh, sorry, the real stuff is what's really matter. But it is a good general idea to sit down and think of what could possibly go wrong with my code and test for that. I'd say one of the problems is that as you find yourself constrained to creating these tests, you also try to do them as fast as possible to get to the code that you want really to do. And the second problem is especially when code is evolving, as it does with agile programming, is that it is hard to keep up with the tests, because we need to update our tests all the time. Yeah, there's more about that in the book. and they're typing, so let's take some water. My idea is that we will keep talking for a while here, and we will end this a little early instead of having a break. Are we supposed to use TDD in our assignment code? Well, not for the first assignment, that's quite okay. But you will know more when we get to the testing phase. As it is right now, we just talk about the different subjects. Okay, to get a bit more management around agile development, they also invented Scrum. Have you heard about Scrum? Still one of the more widely used ways of doing it, and it can be done in a few different ways, but this one is quite a nice picture of what it entails, namely to create some sort of backlog, which is the entire project, and you select a few of these items to put into a sprint and put it then into a sprint backlog, and you do this during a sprint, and then you ship or you review the outcome. When you review it, you show it to a real customer and they can have input on it. So it's really well structured, and it's quite easy to get management on board on this as compared to, for example, XP, because they see the benefits of this organized. We just got a question. Is XP used today? Well, I'd say it's not widely used anymore. We've taken ideas from XP, but I'd say there's quite few places where XP is really done as it was intended in the beginning. But Scrum is still used. We have, I called it a sprint. What is a sprint? Yeah, so it's the iteration during which we perform analysis, design, implementation, testing, and also deployment if we need to. So all the different steps, and we do this perhaps during 2 to 4 weeks. Is somewhere there is a normal length for a sprint, and we really do try to concentrate into creating something that's actually working in the end, so we can show, we pick the different items that we should do, so that the end result will be something that we can show for the customer, and they can have a say, give feedback onto this, and if we need to make corrections to what we've done, then we put that into the next sprint, and otherwise we just pick a new set of items to use in the next sprint. And 2 to 4 weeks, because we do not want to get too far into the project, because the problem is that if we get too far, it will cost us too much time and effort to redo or cope with the change as such. During these sprints, we should each and every day have a Scrum or Scrum Meeting, which is one of the significant things in Scrum, namely to have a daily meeting. Does anyone know or have participated in a Scrum Meeting? No. The idea is that you have 15 minutes, and during these 15 minutes you talk about what you did yesterday, what you're going to do today, and what could stop you from completing what you're supposed to do today. And here again is the idea that we want to catch problems as soon as possible. So if I said yesterday that I wanted to complete user management, for example, and I today say that, well, I didn't, because I didn't understand the code, or something wasn't working, or whatever it might be, then it's fairly simple for us to catch this and have someone else help out, or fix the resources that weren't working, or whatever it might be. And the same goes for well, what I'm going to do today is basically what I'm going to do, and also what could stop me from doing that is a good control question, because you really think of, well, if I know that the system administrators are going to make an update to this development service that we are using, then that might be a cause for stopping the development that I think I should do, or the network is going down, we know it's going down, or it might be going down, it's been going up and down, and so on. So when we know, basically, because I mean, we can't take that to the extreme. We can't say, well, I could make a fall in the stairs and die, so I won't complete my task, because that could always happen. But as far as we know and can say. And important during these meetings is that we stand up and that we do not drink coffee. Why? Or tea, or any other hot beverage. Not even cold water. Why? Why is that specifically said? Well, to focus. If we get a cup of coffee and we sit down in a comfortable chair, it's difficult to get anything done in 15 minutes. So, and that's the idea of these meetings. Rather to have, it's better to have a 15-minute meeting every day than a weekly meeting on Friday that drags on for ages. And to keep time at a minimum, we are supposed to be standing up and not drinking any hot beverage. Where I worked, we tried to use this. The problem was that we had these, I wouldn't say cubicles, but we had rooms where the top half of the rooms were all in glass. So if you walked in the corridor, you can see the heads or whatever it might be on each and every one. And I was the Scrum Master or project manager for one of these projects, and the rest of the guys were in Oskarshamn, another city. That meant that for 15 minutes each day I stood up with a headset and I looked at all the other people, and everyone looked at me thinking, what's he doing? He's strange. And that has continued, but they really thought, what's happening? And that felt very uncomfortable, I'd say. And that's one of the things that is important to think of when it comes to Scrum, namely that it was invented or intended for situations when the entire team is in one place. If we have large projects, it's most often the case that people are in different places, and there might be larger teams in different places. How could we possibly cope with that and still be using Scrum? More Scrum Masters or distributed Scrum Masters. So exactly what we call role replication, or product architects, and so on. That we try to to distribute and do the same thing in different places, and having this, instead of having scrums with everyone, we do scrums, the scrum of scrums, so we have scrum meetings just in these different places, and then the scrum masters have an additional scrum meeting together, perhaps to get up and knowing on what's happening in the different places. But yeah, basically that, try to distribute the problems, so to say. And this works fairly well. The problem is that another of the ideas with Agile is that you should really, and that was also one of the ideas with XP, that you should feel for the code that you are creating. And that means that you should be working, if everything is done as it should, you should be working in a small team with this project full time. However, that's seldom the case in at least small or mid-size companies. So we were about 25 to 30 people where I worked previously, and we couldn't possibly dedicate 4 or 5 people to one project at a time. So if there was one guy who was really, or girl, really good at databases, for example, and in this case it was a guy, and his services were needed in almost all the different projects that we had, and that meant that he went in and made the database stuff in a number of different projects, and that is not ideal, because for him it was just the databases, so he didn't get the feel for the project. And that's something that you want in a real Scrum project, that you are not only a specialist in one thing. So it's even the case that if, let's say, you are a database specialist, you are not only supposed to work with the databases, even if you got full time in this project, because everyone should share a number of the different tasks, from analysis to design to implementation, testing, and so on. And that's because we want to make this our project. Yes, let's move on. There's again a lot more of information and key points and exercises and so on that you can look at and do in order to understand it even better. But further down in the book we have 2 more chapters that we are going to cover today, even though we are going to make it a little bit shorter. Project management is to know how to manage the project itself. So the process is how we perform the different things, in what order we perform them, and so on. Whereas project management is one step up to find the right personnel, staff, to have, or that's a nice quote here, to see to that we deliver the software at the agreed time, within budget, meeting customers' expectation, with a well-functioning development team. So that means that we need to structure everything around this, and it's a job for the project manager or Scrum Master, whatever you'd like to call it, to see to that all of this works. So this is also something that's true for any engineering project. So if we want to build a boat, for example, it's the same thing. However, there are a few key things that makes it makes software engineering different from, for instance, building a boat. And do you know what that is? There are 3 points listed here, but there are many more differences as well. But 3 key points that's different. Water break. Sorry, to get them going, or to yes, exactly. It's what the book calls the product is intangible, meaning that we can't see it. And and then you say, well, we can have a user interface. Yes, of course we can have a user interface, but I'd say that the user interface is a fairly small part of the application, and we can create, just as you're mentioning here, we can create a user interface, and then the rest of the time we need to work with whatever's behind that. So the all the logic, all the database access, everything else that we have on the other side behind the user interface takes a lot more time and effort. And for the customer, they don't see any difference. Whereas if you build a boat, you build it and you make different parts, and the customer can see that, well, this is turning out nicely. It's got, I don't know, I can't build boats, but it's got all the stuff that I expect from a boat, and it's floating. Great. Anything else? Yeah, exactly. So large software projects tend to be one-off. If we build large luxury liners, cruisers, boats, that kind of thing, then they are perhaps a bit more one-off. However, they probably still have more or less the same mold to begin with, and if you create a boat, you want to reuse that and sell hundreds of that and so on. But just as you said, when we do this, we most often create something that just one customer is going to use. We can, as I said in the beginning, we can have the software being built by smaller pieces that we reuse, and we should do that. I mean, we always had the same user management part in all our different projects. So we just integrated the same way of handling users in all projects that we created. But apart from that, I mean, this mineral fetching application that we try to create, there's very few companies who wants to have exactly that. So that's true. They also say that software processes are variable and organizational specific, so it's not the same way of creating software all the time. And there are a number of things that you need to think of when managing a project because of all of this, but in all engineering projects. It's to plan for the project itself, to manage risk and people and reporting and writing proposals. And as I said, one of these really important parts is risk management. It's really important. What do you think a risk could be for a project? Are there different kinds of risks? Yeah.
There are risks that the project runs late.
Yeah, definitely.
And people might get sick or even
Die. Yeah, so running late, killing off people, or just getting ill, and so on. Yeah, we usually categorize this into three different types. So we have project risks that affects the project itself, and we have product risks, that affects the product that we're going to create. And we have business risks that is about the business need and business side of it all. So could you identify something that might be a project risk? If we categorize something of what you've said previously here, what would you say that it is?
Sickness.
Sickness, for example, is what is that? Is this a project, product, or business risk? It's definitely a project risk. So it will affect, and that goes if they're sick, or if they are they might not be the ones that are ill, but they're kids, or they take a vacation, anything like that. It affects the project itself. We'll see if they type some examples over here as well. But the same goes for and knowledge, of course, is a project risk. Do we have the correct knowledge? Can we get the correct knowledge? And that goes for when people disappear from a project, whatever reason there might be, is a real project risk. However, when it comes to knowledge, we can see that is as a product risk as well. If we don't get people with the correct knowledge, that can affect the product itself as well. So we're not able to create the product that we intended because the people doing it are not as clever as we would like them to. So things can be both at the same time. And when it comes to other product problems, it could be software tools that are not working as we intended. Could be that we are using software. We buy software components, for example, and it turns out that these are not working as advertised, and that has happened in numerous occasions for us as well. We bought a number of components and they were said to do this and this and this, and when we tested them out there were bugs in them, and that meant that our product was both delayed and it wasn't performing as well as we intended it because a third-party product wasn't working. How about business risks? Yeah, exactly. Another company can release a competitive competitor. Yeah. And it doesn't sell. That's definitely a product risk, and that might be because there's another product. Yeah. Yeah. Okay. So a number of different risks that could be possible, and I think when it comes to risks, one of the more important thing is to have it analyzed. So you make something like this on page 649. Yeah, and this contains a number of risks that we can identify. It also has a probability rating, so from low to moderate to high, and also the effect that this risk has on the project if it actually occurs. So, for example, they have as we talked about previously, it is impossible to recruit staff with the skills required, and in this case they put that as a high probability and the effect would be catastrophic. And then you do a list, and you at least take your top 10 risks, and then that means those that you think will actually happen, or there's a high probability that they happen, and you take these catastrophic ones as well and make a top 10 so that you know where to monitor and plan for these risks. And when it comes to risk planning, we can have avoidance strategies, minimization strategies, or contingency plans. And what might that be? If we look at avoidance strategies, could anyone think of an avoidance strategy? For example, we know that there is a high risk that people will be away. They will be on holiday. There's a big holiday somewhere in the middle of our project, or people tend to get ill and so on. How can we avoid that this becomes a problem? Well, we can have more people. We can have overlapping people, so that if one is away, there's always another one that can do potentially the same stuff. The next one is minimization strategies, and it's the same with staff illness there, actually, as an example. What can we do to minimize illness with our staff? Okay, so loads of companies that they pay for the staff getting exercise. They see to that the staff gets vaccines during flu periods, and so on. All of that are strategies that we can use to minimize the risk for something like this to happen. And a contingency plan, what's that? That's basically when we bend over and take it. But we've prepared for it. So, yeah, I also got images in my head now that I didn't want. Sorry for that. So, we know that things can happen, but we can make some of these strategies in order to just well, deal with it, or which is fairly common in the US, for example. Yeah, I'll take that in a second. For example, in the US, they take insurance in order for them to be prepared. That is, they take the risk and they put it on someone else. So if the project doesn't go as planned for any one reason, the customer gets paid by the insurance company instead of by us. We got a question: how do we prepare for organizational financial problem forcing reductions in project budget? So if money disappears for us, and that's of course something that's always difficult to prepare for, and if it's high or medium, well, it depends on the company. I would say that the impact of it, the effects of it, would be serious to catastrophic, especially if it's high, and perhaps the problem is difficult in that case to really solve. It might be that we have to take that one. So trying off a contingency plan, either it works or it won't in that case.
Perhaps you need to discontinue a feature or
Yeah. That might be a way to solve it. Yeah, to make the project smaller, to shave off stuff that we don't need to create right now. But that also depends upon what we've said in the contract to our customer. How much can we do that? We could also ask for more money from the customer, saying that this will cost us and thereby you more. But again, that is very much depending on what we've said in our contract. Okay, more about motivating people, teamwork and so on. You don't avoid the project. Well, if most of these risks or the risk planning is if you're going into the project. If you do all the risk analysis before we start the project, and you see that this is the financial problems are real and they might very well be coming, then of course abandon the project before you start. But you need to be quite certain about this. Yeah, as I said, there's a bunch more about project management. Try to read it, and we will stop. Or we will end with a little bit about project planning, which is again one up. So planning before we start the project, and what they talk about here is the to begin with the pricing. What price should we give the customer of this project? And what's important to remember there is that it's not simply the cost plus profit, but there's a bunch of more things that actually costs money in a project that aren't directly related to the project. And what might that be? What is the customer not paying for directly? Employee costs, especially for the people not involved in the project, so the manager and bunch of administration people, not the least system administrators. There's often one or a few administrators in the organization that help you get your work done by setting up servers, installing software and so on, so that you don't need to, but they need to be paid by someone. So each project will take a little bit of that cost, and the same goes for the hardware and software costs as is. There might be times when the customer is paying for specific hardware and software, but most of the time we have our computers, we have our servers, and they need to be paid for as well, a little bit by each project. And then as well traveling and training costs and so on. And there's quite a lot of interesting things to discuss concerning pricing, which you will have to read. When it comes to plan-driven development, I just want you to notice that when it comes to project plans, it says that a project plan for plan-driven, that is waterfall, incremental and so on, we have an introduction, an organization, a risk analysis, hardware, software, resource requirements, a work breakdown, a project schedule, and monitoring reporting mechanism that should be in this plan. And that's basically what you have in that template that we've uploaded to Moodle. So you can read more about the planning process and what should be in the different parts of that document by reading here. Not the least the project scheduling with effort and duration and dependency and so on, which I really recommend you reading. And you can do nice graphs like this, for example. They are ugly as sin, but it's something that management really likes, and they are really useful for handling the project. And last but not least, it talks a little bit about estimation techniques. So the biggest problem with software development when it comes to when is it done is to estimate the time it takes to do different things. And there are a number of, or rather there are two ways that the book at least presents that we can make estimations. And what would you think those two are? Yeah, experience-based, or yeah. So either we have estimation based on previous experiences, that's I'd say the most common, or you have a mathematical formula that you fill in the different parts in, and then you get something that's possibly an estimation of time and resources it will take. And there's this Kokomo cost model that you can read through and get an idea of how it works, but you don't need to know all the details of it. But with that, we've actually covered the 4 chapters. You need, of course, to read more, because when you get the questions in the online exam will be from this book, and it will help you greatly if you've read it so far, so that you know at least where to look. And you, as I said, you've got 30 minutes to complete the test when it has started. And the test consists of 10 questions, and you need 6 of them correct to pass. Alright, we didn't have a break, so I think now is a good time to break. Go break yourselves. No, don't do that. Thank you very much for today. Hope to see you soon again.